Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. In today's video, I am going to continue solving KSET 2025 Physical Science question paper. Yes, let us start with the first question. We have the first question here. The first question says if the electrostatic potential is given by phi which is equal to phi naught x square plus y square plus z square where phi naught is constant, then the charge density giving rise to the above potential is. So they have given the potential, we need to find the value of charge density. Okay, so for that we have the formula from the Poisson's equations. So what was the formula? So the formula is del square phi which is equal to minus rho divided by epsilon naught is the formula, right? So this is the formula. So we need to substitute the phi value in the Laplacian form, then we will get the value for rho. So we shall do step by step. Let us take what they have given. So they have given phi value to be equal to phi naught into x square plus y square plus z square. This is the given value, and we need to substitute this phi in the Laplacian form. So I am telling here Laplacian form. What is this Laplacian equation or the Laplace equation? So the Laplace equation, that is del square, is nothing but my Laplace equation. How we define the Laplace equation? So we define the Laplace equation in the Cartesian coordinates. Means here they have given the potential to be in the x, y, z. So in the Cartesian coordinates we define del square, that is Laplace equation, to be del square divided by dou square divided by dou x square plus dou square divided by dou y square plus dou square divided by dou z square. Okay, so that is the partial derivative of x twice, the partial derivative of y twice, and the partial derivative of z twice we are doing. Okay, so del square of phi will be del square divided by del x square of phi x. Means why I am writing only phi x here means that is the partial derivative. We do partial derivative with respect to x for x only. Here y and z remains constant for this function. So here the function will be x only and y and z will be constant terms. That's why we are not taking into the consideration. Plus del square divided by del y square of phi y plus del square divided by del z square of phi z. In this question, phi x will be equal to phi naught into x square plus phi y, which will be equal to phi naught into y square plus phi z, which will be equal to phi naught into z square on taking phi naught inside the bracket. So here I observe phi naught is a common. So phi naught I'll take out. So del square phi, which will be equal to phi naught. Now partial derivative of x twice of phi x. Phi x is, I have taken phi naught already outside, x square. Okay, so I'll write here bracket plus del square divided by del y square of phi y is what? Y square plus del square divided by del z square of phi z is what? Z square. So do the partial derivative now. I hope you people all know the partial derivative. I will do for first term. So now we have here what we have del square divided by del x square of x square. No, first do the partial derivative of x square one time, you will get 2x. Now partial derivative of x square, again if you do the differentiation you will get the value to be 2. Likewise you will do for y square as well as for z square. If I do, I'll get the value del square phi, which is equal to phi naught del square divided by del x square of x square is 2. Likewise y square will be 2. Likewise z square will be 2. So you will get the answer 6 times of phi naught, right? So we got del square phi which is equal to 6 times of phi naught, which implies that rho will be equal to negative of del square phi into epsilon naught. So what is the value for del square? We have the value for del square to be minus 6 phi naught into epsilon naught will be the value for rho, that is the charge density. So which option is the correct option here? Minus 6 phi naught epsilon naught. So option 2 is the right option here. Yes. Let us continue solving next question. What does the next question says? A cylindrical conductor placed in a uniform electric field E naught with potential V at a point outside the cylinder, which is given by V, which is equal to minus of 1 minus A square divided by R square E naught or cos theta. Then the surface charge density of the conducting surface is. So we need to find again the charge density, but they have given here surface charge density. So let us solve this question. So I'll write down again the let us start solving the next question. So they have given the V naught value to be equal to minus of 1 minus A square divided by R square E naught or cos theta. Yes, they have given this value. So what they have given, you need to find the surface charge density. So what is the relation between the surface charge density and the V out? There is no relation. So we have the relation between the surface charge density and the electric field. So we need to write this V out or the potential in terms of the electric field first. So E, which is equal to minus gradient of V. So gradient, how we define this gradient? In which kind of coordinates they have given? So they have given the coordinates in terms of r, theta and z. R, theta and z will be the cyclic coordinates. Okay, r, theta and z will be the cyclic coordinates. So in cyclic coordinates, I am going to define this gradient to be equal to E, which is equal to, that is minus grade of V, no? So gradient will be equal to dou divided by dou r of r cap plus 1 divided by r dou divided by dou theta of theta cap plus dou divided by dou z of z cap. So no need to worry about the z because they have not given the z terms here. So gradient of V we need to find. So gradient of this potential. So we are they have given in terms of the product form. So let us take V out completely for this dou divided by dou r plus dou divided by dou theta also. Now in the question also they have given negative, and here electric field it is nothing but the negative of grad of V. So negative of negative it will be positive. So electric field which will be equal to grad of V, that is equal to dou divided by dou r of 1 minus A square divided by R square E naught into R cos theta plus 1 divided by R dou divided by dou theta of 1 minus A square divided by R square into E naught R cos theta. Right. Now take this E naught R cos theta inside the bracket and then differentiate. So dou divided by dou R of E naught R cos theta, right, minus of dou divided by dou R of R get cancelled. So 1 R will be remaining, A square divided by R cos theta. This is what we get, right? And E naught is also remaining. So E naught I am going to write here. Yeah. Plus now this is only the R. Coming to the next part, this is only the dependence of R. So I can take outside the bracket, right? There is only dependence of the R and it is a constant. So I can take out the partial derivative of with respect to theta. So 1 divided by r 1 minus A square divided by R square of dou divided by dou theta of E naught is also constant, let it be inside only for a while, R cos theta. So what we get, differentiating, so we'll get dou divided by dou r, E naught is constant here, cos theta is constant, differentiation of r with respect to r partially is 1, so minus of e naught is again constant here, a square is constant, cos theta is constant, so differentiation of dou divided by dou r of 1 by r, so we'll get the answer to be minus 1 divided by r square according to the derivatives. So here it is constant 1 divided by r, 1 minus a square divided by r square. So e naught is again constant, take it out, r is constant, take it out. So dou divided by dou theta of cos theta. What is the derivative of the cos theta here? Cos theta derivative will be minus sine theta, right? This is what we get. Now look here, we have e naught cos theta minus minus of minus, it will be plus e naught a square cos theta divided by r square of, what is this term? This term belongs to r cap, plus 1 divided by r, 1 minus a square divided by r square into minus of e naught r sine theta into theta cap. Now, how you define what is the relationship between the charge density and the electric field now? So that charge density and the electric field is given by the relation sigma, which is equal to, that is a, they have given clearly it is surface charge density. So sigma, which is equal to epsilon naught into E perpendicular. What is this E perpendicular? Means E perpendicular is a radial component. So sigma, which is equal to epsilon naught into ER. So ER means only this component at R, which is equal to A. So we need to substitute for R to be equal to A. So what I get? So from here, sigma, which is equal to epsilon naught ER at R, which is equal to A. So this term, in this term I can write, take E naught common, cos theta common. What is left inside the bracket? 1 plus a square divided by r square. Instead of r, I need to substitute for a. So it will be a square divided by a square, right? A square get cancelled. So 1 plus 1 is 2. So I'll get sigma value to be equal to epsilon naught, 2 times of epsilon naught E naught cos theta. So 2 times of epsilon naught E naught cos theta, which is the answer. So let us go to the question. So your answer will be option 2, that is 2 times of epsilon naught E naught cos theta. So tick for the second option, right? Let us move on to the next question. What does the 40th question says? Two positive point charges, each of magnitude plus q, are fixed on y-axis at the points y, which is equal to plus a, and y, which is equal to minus a, respectively. The potential at any point on the x-axis is given as, the potential they have given on the x-axis, that is v, which is equal to 1 divided by 2 pi epsilon naught q divided by square root of a square plus x square. This was the potential they have given on x axis. Okay, so the value of x, so we need to find the value of x. Yes, uh, the value of x at which the potential is one of that of the origin, means v of x is equal to half times of v naught. Why? What is this v naught? Means the potential at origin. So at origin the x value will be 0, right? Substitute for equation 1. What does equation 1 implies? So equation 1 implies that v naught, which is equal to 1 divided by 2 pi epsilon naught q divided by square root of x is a square plus 0 square. 0 square will be 0, so square root of a square is only a. So this is the v naught, and we have the vx value. Substitute in this equation, we get vx is 1 divided by 2 pi epsilon naught q divided by square root of a square plus x square, which is equal to half of 1 divided by 2 pi epsilon naught q divided by a, right? 1 divided by 2 epsilon naught get cancels on both sides, q get cancels on both sides. What is remaining? 1 divided by square root of a square plus x square, which is equal to 1 divided by 2a, right? On cross multiplying, we get 2a, which is equal to square root of a square plus x square. On squaring, we get squaring on both sides. If I square on both sides, square root get cancelled. Here it will be 4a square, which is equal to a square plus x square. So x square, which is equal to 4a square minus a square. So x square, which is equal to 3a square, or x, which is equal to plus or minus 3a. So square root of, sorry, it is plus or minus square root of 3a. If you take the square here, 3 square root is not there for a. So I am rewriting again x, which is equal to plus or minus square root of 3 into a. Okay, so the correct answer will be here option 3 is the right answer, that is plus or minus square root of 3a, right? Yes, let us move on to the next question. What is the next question we have? So we have the next question to be, if the electric and the magnetic fields of a plane electromagnetic wave are proportional to I cap minus j cap and I cap plus j cap respectively, then the wave is propagating along the direction where I cap, k cap are the unit vectors along xyz direction. So we need to find the wave propagating along the direction, in which direction the wave is propagating. So electric and the magnetic fields, they are perpendicular to each other. It is an easy question, so we shall do using the um, properties of electric fields and the magnetic fields. Let me take the pen. Yes, let us start with the question. We have a 41st question. So electric field and magnetic field are perpendicular to each other. Okay, and the electric field value they have given to be equal to what they have given. Let us go back to the question. They have given it to be I cap minus j cap. Yes, I cap minus j cap. So the magnetic field they have given to be, let us go back to the question. The magnetic field they have given to be I cap plus j cap. Yes, yeah, it is I cap plus j cap. So the wave propagates along the direction. So wave propagates perpendicular to this electric field and magnetic field. Even the magnetic field and the electric field are perpendicular. So we can solve this problem using the cross product, that is E vector cross B vector. So E vector cross B vector, which is equal to magnitude of, or the determinant, you can say determinant of I cap, j cap, k cap. Let us take 3 cross 3. Next, for electric field, it is I cap minus j they have given. So it will be 1, write the magnitudes, 1 minus 1, and k cap it is 0, 0 k cap it will be. A magnetic field, it will be I cap, the magnitude is 1. For j cap, the magnitude is positive 1, k cap it is 0. So in my previous classes, I explained you how to take the determinant and how to solve the determinant. You can watch my videos for this solving. So I am taking here plus minus plus to solve determinant plus I cap. Remove this first row and the first column and take this terms. Determinant of minus 1, 0, 1, 0. Next, similarly, minus j cap. Remove the middle column and the first row, it will be 1, 0, 1, 0 determinant plus k cap into determinant of 1, minus 1 and 1, 1. So now plus I cap, how to solve the determinant of 2 cross 2 matrix. Just cross multiply, and in the mid you will get cross multiplication of minus 1, 0, minus of 1 into 0. So anyhow I'll get 0 minus j cap of 1 0 is 0 minus 1 0 is 0 0. Only I'll get plus, I'm writing negative, plus k cap of 1 ones are 1, 1 ones are 1 like this, negative of a negative of 1 into minus 1, it will be minus 1. Okay, minus of minus, it will be plus 2. So what we are getting? We are getting here to be 2 times of k cap. Means what they have asked, they did not ask any magnitude, they just asked what is the direction. So direction will be k cap only. So the wave is propagating along the direction k cap. So option